And now Mahar is the director of the University of the Philippines Resilience Institute and has spent a good part of the last 20 years working on disaster risk reduction of all types and resilience. And I'm very happy to have Mahar as our first speaker for this series of seminars because um, I see the Philippines as one of the leaders in resilience activities and resilience science. They are both an example for us all and a place where many of the problems dealing with resilience and disaster risk reduction are acted out. So without more to do, I'd like to invite Mahar to share his screen and we will get on with the seminar. Thank you very much.
Okay. Um, can everybody hear me? Yes? All right. I've been asked to make a presentation about artificial intelligence and how it can help in disaster risk reduction. So I have a PowerPoint that was prepared by an AI expert, actually. His name is San Ojeda. He's very young. He's just about to graduate. But, okay. Is it working already, the screen, Ben?
Yes, we can see your screen.
Yeah. Okay. This one?
That's
Can it
good.
be seen?
Yes.
Yeah. Okay. As I was saying, the presentation is about artificial intelligence in disaster risk reduction and resilience. I'm not a computer science expert, either do I claim to be, and I know very little about artificial intelligence, and that's why we have a co-presenter here who's also in this WebEx meeting. His name is San Arthur A. Ojeda, and his work is about artificial intelligence. The reason
Mahar, just to interrupt, sorry, we've lost your screen.
Oh,
sorry.
Really?
I think it may be a problem from my side.
Okay, let me go back. Stop video share. How do I share the screen now? I'll stop it first.
Yes.
Then I will share again. Start broadcast. 2, 1.
That's good. I'll stop playing around and let you carry on.
Is it back?
Yes, it's back.
All right. So his name is San Arthur A. Ojeda. He's just about to graduate, but he's very knowledgeable about artificial intelligence. In fact, he prepared most of the slides in this presentation, and I just added some to give perspective about how AI can be maximized or utilized for risk reduction efforts in the Philippines. So the examples that I will be providing are both conceptual and also the applications that are already being done in the Philippines when you talk about AI. So what is AI? I'm sure you've heard about this. That will be the first part of the presentation. Why use AI, some of the applications, and I'll end with some conclusions, summary, and future direction. Now, AI, for the benefit of those who aren't familiar with it, it's also for my benefit. It's a brief introduction to artificial intelligence, what I'll be saying. It's a branch of computer science that deals with the design and implementation of computer systems that are capable of solving problems that usually require human abilities. You've also might have heard about the term machine learning. It is actually a subset of AI that deals with computer systems that are able to learn from data and consequently improve their performance. Machine learning enables an artificial intelligence system to learn and solve problems without being explicitly programmed. An AI system can be used for various real life applications. Like I'm sure you've heard about this, Alexa. I use this in my home. Google Assistant, Siri, if you're using iPhone, these are digital assistants. Chatbots, Facebook Messenger bots, self-driving cars, Tesla, facial recognition. You have the Facebook and Snapchat. Snapchat. I'm sure many of you are using these applications. And most of these utilize machine learning to learn from users and become contextually aware to further improve as time goes by. Why use AI in terms of disaster risk reduction and resilience? The answer is very simple. Scientific and technological advancements such as AI are being leveraged or can be leveraged in order to reduce disaster risk and improve disaster resilience in cities and communities. Of course, in the battle against hazards, we need to have the best tools, the best equipment, the best technologies to be able to address the problem the best way we can. So we have AI and there are applications and might as well use them to our advantage. AI is data driven. Um, it strengthens existing efforts in disaster risk reduction and management through adaptive and timely means. So I'd like to explain at this point why I'm interested or we're interested also in making use of artificial intelligence. Since 2012, we have embarked or we have been doing disaster risk reduction efforts that make use of, or at least we would like to think of it as the best technologies available in the world. So when we were asked by the president of the country what we can do, the University of the Philippines, to help in the disaster risk reduction efforts after Sendong, because there was a big disaster that flooded big cities in the southernmost island of the Philippines. So we came up with a program highlighting open data, highlighting probabilistic risk assessment, the use of technologies, the use of LiDAR technologies, flood modeling capabilities, and it must be made nationwide and must be available to the public. So we built a platform. It's called as the NOAA website, NOH. Now it's noaa.up.edu.ph. It shows satellite images from freely available platforms. You have the different forms, the GS map, Himawari, and available track data when there's a storm entering into the Philippine area of responsibility. The radar data of the Weather Bureau, we deployed almost 2,000 sensors that stream online data, rainfall data, weather data every 10 minutes. We contoured all of the rainfall data so that we know what part of the country has torrential rainfall. And we also did flood models, high resolution ones for the entire country for different scenarios, and have netizen accounts to validate the flood models that we create. Now, the validation seems to be very good. Flood hazard maps, landslide hazard maps for the entire country, including debris flow hazard maps, have been created. We also created the storm surge hazard maps of different types for the fifth longest coastline in the world. You can see the provincial administrative boundaries, the municipal boundaries, and the hazard maps can be seen up to barangay level. And that's how high the resolution are. Now, we're trying to continue to update this with demographic data, the location of schools as well, the location of fire stations, police stations, uh, uh, including dengue. But I don't think this one worked. It stopped sometime about a couple of years ago. But what we're trying to do here, or what I'm trying to show, is that uh, we have collected a lot of data over the years since 2012. And with AI, what efforts that we have made could be possibly improved with that kind of technology. Now, um, in the NOAA website, we also have what we call as the rebuild platform. So we don't only have the hazards data, we also have risk information. Basically, what we're doing now in the University of the Philippines, this university being a national university and having the responsibility of doing public service, we go to the communities, the local government units, and help them out in their planning. So we also built an online analytics platform where you can see the hazards and combine it with the uh, information uh, from the LGU, including demographic data such as population, where the critical facilities are, the lifeline utilities, the natural resources in the land, in the area, as well as the urban use. So basically, we're trying to convert the hazards information into useful knowledge for the community. We want to convert the hazards into risk information that may be useful for development planning, so that when the hazards make their impact on that community, the community and its people are resilient. They have planned well, and the development of the community goes unhampered by the hazards. But that's a long story. It will take probably a whole day for me to talk about what we've been doing in NOAA. But I think the takeaway message here is that since 2012, there have been a lot of data that have been made available, and a lot of data that we have seen stream online. And throughout the years, we have developed a lot of experience also in looking at the various assets. And these assets have that lens of humans on how they are used for disaster risk reduction. Now, if we combine that with newer technologies, we might be able to use that experience and to train or to input some uh, some insights or some of the experience into getting the computer to find the things that are important. So basically, we will get the artificial intelligence and computer science experts to work on the problem with some of our guidance, using some of our experience, so that they can eventually also make codes or make programs that are intelligent, and that would basically be taking also some parts of the experience that we have developed over the years. So this is the risk information. That's the hazard. We can always overlay them. And once we are able to do that, the computer can also show to those who are interested um, what kind of data is available and information are available online in table form. So what you're seeing here is the different hazard maps and also the demographic data. So it automatically should be able to calculate if you need to update the demographic data. That should be easy in this platform. We have also during the COVID maximized the or utilized or tried to get the expertise of the various people in our university, because our university is composed of 8 constituent units, and we have about 22 campuses distributed all over the Philippines. So what you're looking at here is a website called ncov.ph, wherein you see some of the number crunching, the statistical information that were churned out by our experts, the modeling experts. So I enjoin you to look at this website and see what we've done. Part of this website is also a chatbot, but it's not truly artificial intelligence yet, because I think there's a strict definition. Some of the people online use it in a loose manner, but I was told that the chatbot that we put in this site was not exactly AI, but some would classify that or call it already as AI. His name is Yanni, the NCOV robot, and that is supposed to be a chatbot. But recently we were asked to take it out because of data privacy issues. So that is something that we have to hurdle problems with data privacy issues in the Philippines. Now, why use AI? As I mentioned earlier, we've been looking at the large volumes of data, and the university is planning to get a center established so that we can handle more data sets coming from government. It has received the funding is already approved, so we want to bring in to that center with many servers and supercomputers. We're going to buy, the university is going to buy 3 supercomputers, and we want to be able to do a lot of data analytics. So decision making before, during, and after disasters can be factored in, and as much relevant data as possible can be used and processed. With AI, you can manually, with AI, you can do this with the computer doing the processes for you or thinking for you once it is programmed well. Now, combining AI and predictive analytics to proactively make informed decisions to predictions, we are able to produce, or we would be able to produce better results and insights as to how to effectively respond to, manage, and mitigate disaster risks. Some of the applications I've already mentioned, Yanni, the NCOV robot, which is a chatbot, not truly AI yet, but with further programming, I think it's going to learn by itself. So in terms of real life use cases of AI in disaster risk reduction and resilience, um, well, this has not yet been implemented, but we've been discussing this already with some of our flood modelers. Maybe San Ojeda, I haven't talked to him about this, can help us out in our initial efforts on the use of neural networks for flood modeling. So we've been doing a lot of flood modeling. We've modeled in high detail using LiDAR as topographic base to create floods, but maybe we can improve that further with AI. Now, in terms of Earth observation, usually in the form of satellite imagery obtained by remote sensing technologies, we have been doing that. Actually, for those who are familiar with remote sensing, um, this is actually just the supervised classification. But I was informed that that was actually some form of AI, because you are training the computer to do some processes and to do identification with limited supervision. So we did that for the landslide, debris flows that happened in Gabaldon. This was because of two consecutive cyclones that dumped a lot of rain in the area and generated debris flows. And these debris flows uh, had these communities not have any warnings from NOAA, many people could have died, but they had zero casualties. So what we did there was just to map out after the disaster or after the hazard event the sizes of the grains because they contained a lot of boulders and there were hyper concentrated flow deposits as well, more finer grained material. So there was some kind. This is the work of Carmil Escape, one of the master students that we have now at the National Institute of Geological Sciences, and doing by doing field work and by doing um, a validation of the supervised classification, he was able to map out those true debris flows with big boulders and those that are hyper concentrated flow deposits. And you can see the classification that was made based on some supervised classification. And since then, she has tried to apply it to some other events, trying to classify the different types of grain sizes from remotely sensed imagery. Of course, these cannot replace actual field work, but it gives you already an idea very quickly on what kind of event happened, what kind of debris flow happened, uh, and that is very useful. That kind of information is very useful in trying to find out, especially during search and rescue operations, find out some of the science to help in the work that needs to be done during disaster response. In terms of other applications, this is basically what San Ojeda and the group from DOST have been doing. I know based on the talk that was given by Sun and his advisor that they were able to use artificial intelligence to uh, make better forecasts. They're shorter term than the available forecasts that are normally provided 1 day up to 5 days in advance, but with better accuracy. Now that makes use of rainfall data. They use some kind of code or algorithm in their AI, and the result was, according to the presentation, was that they brought the accuracy up to roughly around 90% or more, and that is a very very important achievement. I would say because when we tested the forecasts here in the Philippines, it's normally very difficult to forecast the amount of the rainfall here in the country because it's a tropical region. The accuracy of those 1 day to up to 5 days forecasts in terms of rainfall was only in the range of 60 to 70%. So we need that kind of application AI to improve our forecasts that are very important in mitigating loss of lives. And also at the ASTI, they use Earth observation data. We're very, very thankful to the Copernicus program, to the Europeans. I think the French are very active with the Copernicus program, and they provide a lot of very useful satellite information or satellite images, which we make use of. DOST ASTI uses that for flood detection. The radar images, probably in particular, Sentinel 2 and Sentinel 1. I think the radar is, if I'm not mistaken, Sentinel 1. They make use of a machine learning model, which is a convolutional neural network approach and we're able to conduct near real time flood detection. So that kind of convolutional neural network approach is a machine learning model specifically used for image processing tasks. In this case, satellite imagery from Sentinel-1A. So this is what I was talking about, and also Planet Dive. That's not sorry, Planet Dove. So Planet Satellite Platform. They provide also daily optical satellite imagery. And being an educational institution, I'm sure Ben uses this Planet because it's got a 3 by 3 pixel resolution, if I'm not mistaken, better than the Sentinel. But they can be used, they can be processed, and that model is actually being used to generate flood situation maps across the Philippines. The claim is that there is no human intervention, and in less than 4 hours upon receiving the satellite data, they are able to produce this kind of map. Um, so these are very important maps that tell you the current situation. Of course, there are limitations to the Sentinel-1 imagery because their repeat pass is not every day. So it's several days, but nonetheless, uh, it's very, very useful because it has reduced the repeat pass from what we had before, yeah, in terms of Landsat imagery, which were almost a month before they return to a certain location and image that location. So these are the flood situational maps produced by artificial intelligence. They also use it for detecting the cyclone's eye, for estimating the tropical cyclone's eye. Of course, with Doppler, you can see that very well, especially if it's streaming near real time. But it's also important that we make or take advantage of artificial intelligence to extract this information from available data. Uh, San also included this. San Ojeda included that in terms of tropical cyclone intensity estimation, they have developed some kind of program to do that. I end there. These are the sources and references that were included by San. I was not able to put in the sources or references that I talked about early on, those that were related to what we have done under Project NOAA, or it stands for, the NOAA stands for Nationwide Operational Assessment of Hazards. Thank you very much for listening. Thank you, Ben.
Thank you, Mahar. That's very good. That's superb. I hope you can hear me. I sound a little bit blurred to myself.
I can hear you, Ben.
Good.
Very clear.
Excellent. Well, there's already a few questions on the chat that we can start with. Some from me to start us off, but perhaps we can start with, there's a first question from Shireen James Williamson from Jamaica. I don't know, Shireen, are you there to ask the question?
Yes, I'm here, Ben.
Great.
Sorry.
Go ahead.
Morning, everyone. Morning, Mahar. I enjoyed your presentation. I just wanted to find out what platform is NOAA built on, and if it's transferable. For example, what if somebody wanted to use something similar in a different territory, in a different country, if it were transferable, or has it been customized primarily for the Philippines?
Yeah. I don't have examples of the AI yet. No, I just showed the flood models in the presentation to show what we have done over the past 8 years since 2012. Uh, I don't really understand. I didn't understand what platform. If you're talking about open data, we have the hazard maps available to anybody to download, and they are presented in shapefile format, and there are also formats that are in KNZ. So that kind of hazard map is available for landslides and storm surges as well.
Okay. In terms of the platform, I was wondering if it was built out on top of, say, Esri or some open source GIS program, or was it built from the ground up? All the programming done by a team in the Philippines.
Yeah, that programming was done by a web development team. It was built from ground
Okay.
up, and I believe that they have a GitHub. They're in GitHub. The source codes that they used for the platform are available in Git.
Okay. Okay. Cool. Thank you. Thank you very much.
Yes.
Mahar,
So it's not commercial. To answer your question, it's not commercial. It was developed locally.
Great. Great. Thanks.
Mahar, we have a question as well from Julie Morin in Cambridge. Julie, are you there?
Yes, Julie.
Yes, can you hear me?
Yes.
Okay, so you maybe said it, but my connection is pretty bad, so I could not have heard it. I was wondering if your CNN analysis is efficient in the context of multi-hazard events. For example, to discriminate in case of a volcanic eruption, can you have simultaneous analysis of, I don't know, pyroclastic flows, lahars, ashfall impacts, or is it too difficult to discriminate or too time-consuming?
Yeah. To be honest, I'm really not an AI person. Maybe San Ojeda, who's also here, I believe, can answer your question. And maybe also to make it clear, uh, we have made the presentation on the different types of hazards, but the work that has been done by people here in the Philippines are basically more or less limited to those that I have presented in terms of hazards or natural hazards. Uh, I really cannot answer your question on whether the neural network is the neural network is useful and is quite quick in studying the different types of volcanic hazards. Are you from the Department of Earth Sciences?
I'm currently in the Department of Geography, but we work
Yeah.
closely with the colleagues from Earth Sciences.
Okay, all right. Say hi to Clive, please.
Yes, sure.
Yeah. Yeah, maybe Sun can answer that. What he thinks would be the answer to your question. The examples that he gave, I'm sure, are I think are not related to volcanoes or volcanic processes, but maybe he has some kind of idea on how to answer that if the that neural network system is applied to studying pyroclastic flows. I'm sorry, yeah, pyroclastic flows and other volcanic hazards. Sun,
San, are you there?
Hello, everyone.
there.
Hello, San. Go ahead.
I missed you.
Yes, he answered already.
So to answer your question, um, CNN is technically not an analysis tool, but it is used for modeling different kinds of problems. So the approach is actually flexible enough for it to be used for a wide range of applications in different domains. So in our use cases, we have applied the CNN for forecasting rainfall, precipitation, and cyclone intensity. We usually the development of CNN models must be thoroughly uh, work closely with other experts in other domains, such as in weather forecasting, because uh, problems need to be understood clearly so that the model will be able to be, so that we can apply the model effectively. So in short, it can be applied for such use cases.
Okay, thank you.
Thank you very much, Nina. Thank you, Sun. There was a question that I asked and it was picked up by Jacob Jacella. Jacob, do you want to ask the second part of the question? If you're there, you're welcome to do it. Otherwise, I will do it. My question was about updating. How rapidly can the maps be updated? And Jacob was asking whether Typhoon Rolly and Ulysses have already been updated into the database.
Yeah, that is a very good question because we keep on being asked that question. We were able to build our capability to do LiDAR mapping. So rather than to buy it commercially and get the services, we tried to buy the instruments, LiDAR, and develop the capacity to use them, fly the LiDAR, and generate the DTMs as well as the DSMs, digital surface models and digital terrain models. The idea being that after an event such as Ulysses and Rolly, we would be able to fly it and then be able to get the new terrain to be able to simulate the event. Well, that was the original idea. So there were some problems, but that is in principle what we want to do. Now, I can show you a simulation that we made for Cagayan River. If you are on Twitter, you would have seen this hashtag Cagayan needs help. And that the hashtag referred to some cries for help by people in the middle of the night while the floods were happening. And that was quickly blamed on the discharge of a dam that released water up to 6,500 cubic meters per second. So we did that's a lot of water. So some people said that well, that's one of the tributaries that contribute to the massive Cagayan River, which is the biggest river basin in the Philippines. So we tried to look at it by doing a simulation as quickly as possible. And if I can share it, maybe I can show to you the video. Just a minute. I'll just bring it up as quickly as I can.
Go ahead.
Okay, here you go. Yes, so now it's playing. And this is the... Okay, share screen, start broadcast. 3, 2, 1.
We see it.
You see it already? I don't see it yet. There.
Yes.
Okay. So, yeah. So, the conditions that were used here is that we just use the input flow of the release of water from the dam. There's no rain input, just the flow from the dam. The initial condition of the water level of the river is an average or normal water level. But you can see right away that just with the dam release, you can see the floodplains being inundated. So that addresses the question on whether the Magat Dam release contributed a lot to the flooding in that area or to many municipalities in that area. As of the moment, the total count of the deaths in those places is about 23, but they stopped counting. I don't know why, but they stopped counting, just giving numbers without putting in the names of the people who died and the place where they died or where they came from. This is in stark contrast to the normal practice where in previous years we had that kind of system where you are able to see in public or online the names as well as the residence areas of the people who died. So yeah, we can do it quite quickly because we have available data sets. But with artificial intelligence, I guess that can be used to make it more quick than what we can do now. So hopefully we are able to see this kind of situation, maybe build scenarios even before the dam release, so the people can be warned in advance because I've heard that the people could not understand what 6,500 CMS means or what CMS means. But if you show them this kind of map, tell them that it's a map view and how the places will get inundated, people will be able to appreciate better and internalize what's coming. Yeah, so I'll stop again the broadcast and I'm ready again for more questions. And
So I think I was Ben, you have another question, I think.
I'm sorry, I could not hear.
You hear me now?
Yes,
Okay.
it's louder now.
I think I will continue. Ben, you have another question, I think.
Yeah. Sorry, is there are there any litigation problems related to the dam discharge? Because it sounds as though you are providing evidence that there might be the dam discharge is the cause of the disaster and not the rains itself.
Well, I'm not saying that it's entirely due to the dam release, but it contributed a lot. We were looking at the discharge, the timing of the discharge. That could have been because it came after the dam was full already. So 4 hours after, when the dam was full, of course, we know that if it reaches the spilling level, that will be dangerous for the integrity of the dam, of the infrastructure. So they really needed to release it. What we're looking at now is which is a problem actually with all of the dams here in the Philippines. We do not really use the forecast information and trust that science to release the water because releasing 1 meter of dam water would cost several millions of pesos if the forecast was wrong. So they don't they wait for the rain to come and then it's not it's reactive, it's not proactive. So maybe with this kind of data sets, these kinds of simulations, we will be able to convince through policies the government to do some kind of work to make proper use of the forecasts that are 90% accurate, as what I've discussed in the presentation, the work of Sun, 90% accurate, so that the dam managers will be able to trust the science better rather than having a forecast with 60 to 70% accuracy. So if they release early on, like 2 days before, that peak discharge of 6,500 could have been spread out over time, and that could have made, if it's spread over time, made the Cagayan River swell like it did during Ulysses.
Okay, thank you very much. I think we will take the last question, and after we will move on. So about Ruby, if you want to turn on your microphone, are you here?
Thanks so much. Yeah. Thank you, Mahar. That was really brilliant. The question I had to ask has more or less just been answered, actually, in elements. But I was wondering whether there is any issues with broader trust in science and authority, that providing better information might only be part of the solution, and the last mile in early warnings might be the critical one to get people to actually follow science and advice. Thank you.
Of course, that's very true. The last mile. No amount of science, if it's not embraced by the people, will be useful. So we really have to get that science embraced by the people, understand the meaning of what we're trying to generate. And it's quite difficult to do that, really. We need to mainstream all of that information down to community level. We have a law that requires all communities to have what we call as the comprehensive land use plans, with the climate change adaptation plans, disaster risk reduction management plans, and I think 20 other plans that LGUs have to comply with. Now, that is really mainstreaming all of these disaster risk reduction information down to community level. I believe that the presentation of Joy Santiago and my presentation with Ben, I'm not sure. What's that, UNESCO as well, Ben? We
Not.
talked about, yeah, maybe we can refer them to the recording of that video, how we do it, mainstreaming that information down to community level and put them into their development plans. Their development plans are very important because that's the way by which we can address that last mile problem. We also have been advocating for the use of music. Get psychologists to be on board so that we can understand the mindset of the Filipino people, because they have their own belief system, and they have their own ideas of what we think, the science that we want them to think or to accept is not really the way they believe, or what they believe in. So we have to understand the psychology of the Filipino people. We want to ingrain or embed disaster awareness through music, through art, through whatever means, embed it into their culture so that when they take action themselves, they believe in what they're doing. We don't like it to be in the form of discipline, because discipline is something that you do without belief. So with the use of art, with the use of music, long term, you are able to get that information, that disaster awareness embedded into their culture, into their system. That way, they have ownership and they believe it, and they take action responsibly and accordingly, in a manner that is effective the way we want.
Okay, thank you very much. I see we have also Jacob another question. Maybe you can answer Ma quickly, or you can answer on the chat as you want, or I can send you back all the questions by email. You can hear.
Hello. Hello.
Hello, Jacob.
Hello, sir.
Hello,
Hello, Sir Mahar. Hello.
hello.
Apologies for not following up on the first question a while ago. I had to attend to something quite urgent quickly. But
Yes.
as for my second question, I was a bit curious with the virtual chat box that you mentioned. There was a virtual assistant that you mentioned. Am I correct? That could
Yeah.
assist when it comes to answering the public's inquiry regarding weather-related
Right.
hazards. Have you
It's
encountered
called.
any issues when it comes to the
Yeah.
public's
I
inquiry?
mentioned that already. We were informed that the chatbot that we created or that was created by computer science developers or computer science people had some data privacy issues. It did not come
I see.
from the government. It came from the data privacy officer of the university. So we had to comply. Anyway, it has been, I think, 6 months already that has passed. Yanni did its job. It was very useful to others, I think, based on the feedback early on during the first 6 months. So when we were asked that to put it down because of data privacy issues, we, we we took it down because we think that it already served its purpose.
I see. Thank you, sir. Thank you very
Thank
much.
you, Jacob.
Okay, thank you very much, Mahar. It was quite interesting.